Hey there, future paraprofessional. If you're watching this video, it more than likely means that you need to pass the ParaPro exam, right? You might be feeling nervous, or you just want a refresher about all of the math topics that you will see on test day. Well, that's why we've made this video. My name's Elliot Zielinskis. I used to work as a paraprofessional before I became a licensed teacher, and I can definitely help get you that passing score. Now, in this video, we're gonna walk through all of the content that you will see on your real exam, including doing algebra problems, data analysis, as well as measurement and geometry. Now, if it's been a while, make sure that you stick around to the end. Also, if you want to complete this practice test before, during, or after this video, I've left a link to that free resource in the description below. Furthermore, if your test is coming up soon, you want to save tons of time and be given everything that you need in one place, make sure that you enroll into our full ParaPro test prep course, where you'll get the complete study guide as well as 2 full-length timed practice tests to make sure you are ready for test day. Hey, without further ado, let's begin this lesson and complete this math practice test together. All right, here we are at our ParaPro practice test, and we will begin with number 1, all about basic operations. So, first and foremost, I'm looking at this, I see a string of addition problem numbers, and let's take these and add them together. So, we have 10,563. Notice how I'm writing the larger number up top. Next, I'm going to write 234, and below that we have 7. Let's create this addition sign, and let's add. 7 and 3 is 10. Add the 4, that's 14. 3 and 6 is 9. Add the 1, that's 10. 5 and 2 is 7. Add the 1, that's 8. Bring down the 10,000, and we are left with 10,804. Great. Now let me clean this up, and we'll take this out, and we'll move on to number 2, where again I see a string of numbers that this time are subtraction. So let's take this and write the 10,300 up top. 10,300. We have 2,002 below that, and we have 1,001. Again, this is a subtraction problem, so we have 3 minus 2, that's 1, minus 1 is 0. Looks like we are going to bring these down, same with these. Add the comma, and then we have 10 minus 2 is 8, minus 1 is 7. So our difference, or the final answer, is 7,000. All right, nice work. Let's keep it going and make sure that you have your pen and pad out and you are following along with me as well. All right, so next up we have 14 times 5 times 29. Here we go. Let's write this. I'm going to again write the larger number up top. I'm going to start with 29 times 14, and then I'll take that multiplied by 5. So remember, 9 times 4 is 36. 4 times 2 is 8, 9, 10, and 11. Add the placeholder 0, and let's scratch this out. Now we have 1 times 9 is 9, and 2 times 1 is 2. So now we are going to add this up. That's 6, that's 10, this is 4, and we have to take this 406 and multiply it by 5. All right, so we have 406, or 406, multiplied by 5. And 5 times 6 is 30. 5 times 0 is 0, add 3, and then we have 5 times 4, and that's 20. So we'll have 2,030. Nice. Okay, so 2,030. All right, now let's again clean this up just to keep everything neat and clean. Okay, great. Let's move this over, delete that, and also let's take care of this too. All right, now we are on number 4, 9,800 divided by 2 divided by 100. And so what I first and foremost see that will save me time if this was my actual exam is that I see that 9,800 or 9,800 has 2 zeros, and also 100 has 2 zeros. So what I can do is scratch these 2 zeros out, and we'll be left with 98 divided by 2. See how much time that just saved? All right, so now let me go ahead and write this 98 divided by 2. Now I know that I ask myself, how many times does 2 go into 9? That's 4 times. All right, so 2 times 4 is 8. That's 1 remainder. The 8 comes down. Ask yourself, how many times does 2 go into 18? That's 9. And we are left with a quotient of 49. Nice work on that. Okay, so circle it, delete it, move on. Number 5, another string of numbers. Remember that your ParaPro exam will test your understanding of lots of math material, such as basic operations, add, subtract, multiply, and divide, but it also includes fractions, decimals, and percent. So I can see this is now testing our ability to work with decimals. So again, I'm going to write the larger number up top. That's 105.002. Underneath that, 23. And remember, the key here is to line up the decimals. 4, 5, 6, and we have 7.89. 7.89. I'm going to add this 0 as a placeholder. This is an addition problem. Now let's add 2 and 6 makes 8. 9 and 5 makes 14. 8 and 4 is 12. Add one more, that's 13. Carry the decimal down. We have 7 and 3, that's 10. And we have this 6 right here. 10 and 6 is 16. And we have this 2 and 1, that's 3. Bring the 1 down, and we are left with a sum of 136.348. How are we doing here? Is that what you got too? 136.348. Let's go. 136.34 and 8. Okay, so let's take care of this. You know what's next. Number 6, 98.75 minus 43.62. So let's write it up. 98.75 minus 43. Line those decimals up. 0.62. Clear it. We have the bar. Now subtract. 5 minus 2 is 3. 7 minus 6 is 1. Carry that decimal down. 8, 7, 6, 5. And again, 9, 8, 7, 6, 5. We are left with 55.13. How are we doing over there? You good? 55.13. Again, I'm going to go and clear this to keep things nice, neat, simple, and easy. All right, now we are being asked to demonstrate our understanding and ability to divide with decimals. So let's try it out. We have 48.36 divided by 0.12. Ooh, I just noticed something. And again, these are the types of math fundamentals that will help you not only pass your exam, but make sure that you finish it. Now, check this out. I see these two decimals. Both are in the hundredths place. Remember, these are the tenths. These are the hundredths. 0.12 is also in that same place value, which means we can simply eliminate the decimal points and divide this just as if it was a whole number. So let me show you here. 4.836 divided by 12. Now, I'm asking myself, how many times does 12 go into 4? It doesn't. How many times does it go into 48? Well, let me count here. 12, 24, 36, 48, that's 4 times. So let me just erase this. All right, whoop, not that. All right, 4 goes here. 48 actually went in evenly, which is really nice. Let's subtract 0, 0, bring the 3 down. 12 doesn't go into 3, so add the placeholder of 0. Bring this 6 down. Now we have 36. 12 does go into 36. I'm sorry about all this. This is a chicken scratch right here. Let me write that nice. Whoop, there we go. 12 does go into 36. Again, 12, 24, 36, that's 3 times. 3, 6, 0, 0, and our quotient is 403. All right, so notice how that saved a lot of time, was a whole lot easier than trying to deal with those decimals. Now, that only worked because the scale of the numbers were the same. They scaled the same. They're both in the hundredths. Let's go on down to conversions. Ooh, getting a little more tricky. You'll notice that with this practice test, the numbers start from simple and go to complex. So number 8, we have a little fill in the blank. I like these. All right, we have this decimal, 0.375. In other words, is 375 thousandths. So remember that in order to convert this into a fraction, all we have to do is write the number up top, that's 3, 7, 5, and put it over its proper place, which is 1,000. All right, so it's as simple as that. Now I do notice that this 5 and this is a 0, so that means that we could reduce it, but the directions never said to reduce to simplest terms. So we're going to keep it just like that, and now let's move on to converting the decimal to percent. Now in order to convert this decimal into percent, we simply multiply by 100, and when we do that, we just go whoop, whoop, put it right there. So that's over 2 places, so that's 37.5%. Love it. All right, let's go. This one's going to be a little more tricky. This is an improper fraction. Remember, improper fraction is when the numerator is larger than the denominator. We have 9 over 4. How do we make this a decimal or a percent? Well, what I do know is that if, and this is an if, but if it was 4 over 4, that equals 1, but it also equals 100%. But we don't have 4 over 4. However, if we had 8 over 4, which is closer to this, it would actually be 200%. And that makes sense, right? Because we have double the amount out of the total. So what I'm saying is that I don't know what the percent is right now, but I do know it's going to be more than 200 because we have more than 8 over 4. We have 9 over 4. I'm going to use this little section down over here, so 9 over 4, and we are going to actually do some long division. Now, this looks simple, but it gets a little complex. So, how many times does 4 go into 9? That's 2, 8, 1 remaining. You still with me? Good. I'm going to circle this 2 because this is part of our answer. All right, so, but I also know that we have this 1 remainder. We have to do something with that, so watch this. What I'm going to do is I'm going to do a 1 divided by 4. But we know that 4 doesn't go into 1. So I'm going to add a 0. Now watch me here. When I add the 0, now 4 can go into 10 2 times. We have 8, subtract it, that's 2. Now again, I'm going to circle this 2 because this is part of our answer. Both of these are part of our answer. Now I do notice that we're not finished because we haven't found a whole number yet. We have this 2 remaining. Now, stick with me. I know this is like, what? It's been a while. Now, again, I'm going to do the exact same thing. How many times does 4 go into 2? It doesn't. So I'm going to put the 0 there. Now, how many times does 4 go into 20? That's 5. And it goes in evenly, so I know we can finish right there. I'm going to circle these, and all of these 3, 2, 2, 5, those are part of our solution. So the answer is 2, 2, 5. Now, the question here is, where do I put the decimal? Do I put it here? 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 Well, think back to how we discussed that 9 over 4 is just a little bit more than 2 times the 4. It's going to be 200-something%, so I know that the decimal is going to go right here because it's just over 200, right? Now, the percent, once you get this decimal, really simple, 225%. Is that what you got too? Nice. Remember that we discussed this earlier in the first one. When converting a decimal to a percent, you just multiply it by 100, or you move the decimal to the right 2 times. All right, now let's go ahead. Let me clean this up just in case we need the space for next problems. And I see that we are going to be working with one of my faves, greater than, less than, or equal to. Let's go. So we have the less than sign, the greater than sign, and the equal to sign. So, another string of numbers. That means that we are going to be adding these, and then also we're going to be adding these, and then we're going to see which one is bigger, and we will put the greater than, less than, or equal to sign right there. All right, so again, I am going to begin by writing the larger number up top, which is 8,291. That's 8,291. All right. Now, if you're liking this video, if you're enjoying this video, please give it a thumbs up. That's it. Just give it a thumbs up. Again, if you want access and you didn't get this practice test yet, link is in the description below. All right, let's keep going. 8,291. Next one is 3457. 3, 4, 5, 7. And 1, 6, 7, 3. 1, 6, 7, 3. This is an addition problem. 7 and 3, that makes 10. One more, that's 11. We have this right here, that's 10. And this right here is 12. So 10 and 12, that's 22. All right, here we go, 2 and 2. We have this 6 and 4, that is 10. And add 2 and 2, that's 14. There we go. And here we have this 8, 9, and 10. 10 and 3 is 13. So this right here, let me just write this in blue. This sum is 13,421. Now, when we go to the next string of digits, we need to do the exact same thing as we started out with. Again, write the larger number up top if you can. Remember. All right, so we have 9,003. We have 4,512. And we have 789. 789. Let's add it. Okay. This is 5. 5 and 9 is 14. 8, 9, 10. Good. 12, 13. Put the comma. Now we have 10 and 4. That makes 14,300. 14,304. So, which one's larger? I'm going to have to go with 14,304. So remember, we always put the open mouth, as we oftentimes will teach our students, like a hungry alligator, the less than sign. All right, so one more time, 13,421 is less than 14,304. Great job so far. Let's keep going. We have number 10. Ooh, we need to do the multiplication, and now it's checking our ability for fractions. Fractions are one of my faves, so this is nothing but a party. Let's go. 2 over 3 times 4 over 5. Now, the great thing that I really like about multiplying fractions is that you can just multiply it straight through. So 2, I'll write that a little bit neater. There we go. 2 and 4 is 8. 3 and 5 is 15. Now I'm just going to and delete it and move it and write it. 5 over 6 times 1 over 2. Again, just straight through. Multiplication. All right. 5 times 1 is 5. 6 times 2 is 12. Clean it up. All right. Now, I think we can actually even move this. I'm still getting used to it. Boom, look at that. Beautiful. All right. 8 over 12. Oh, no, what I notice here now is that our denominators are different. So it's really hard to compare fractions with unlike denominators. What are we going to do? We are going to find common denominators. And in order to find a common denominator, we need to ask ourselves, what number does 15 and 12 both go into? Let me think here. Double 15 is 30. Does 12 go into 30? No. Double 30 is 60. Does 12 go into 60? Yes. Okay. Nice. Sometimes that's harder than that. Here, 60 and 60. Now remember, in order to go from 15 to 60, we needed to multiply by, what is that? 60 divided by 15 is 4. So that means if whatever you do to the bottom, you have to do to the, you got it. Right at the top, 8 times 4 is, let's keep the colors going, 32. Now, we'll do on the other side. How did we go from 12 to 60? We multiplied by 5. 5 times 12 is 60, so that means we need to take 5 times 5, put it in red right above. 5 times 5 is 25. All right, so now let's actually write both fractions because this is looking way too messy for me. 32 divided by, or just over, 60, and 25 over 60. Love, 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 love the like denominators. Makes life happy, happy, happy. Okay, now All you have to do in order to compare fractions with like denominators is look at the numerators, and whichever one is bigger, that is the bigger fraction. So that means that is the bigger fraction. Nice job. All right, here we go. Delete it. Here we go. Delete it. Moving on down, you're doing great. If you're sticking around here, you are well on your way to pass your ParaPro. Again, I used to be a paraprofessional. It was an awesome job, and I absolutely loved it. And after 2 years of doing it, I transitioned into becoming a teacher. And maybe you'll do the same. But hey, if not, I'm here to help you pass this exam. That's what's important right now. Let's take a look. We have, decimals, multiplying decimals. It's no problem, though. We've got this. 0.3 and 0.9. I know that 3 times 9 is 27, so I'm just going to put 0 and a point right there. And this is going to be 0.4 times 7. 7 times 4 is 28. Ooh, these are close, but not close enough. All right, there we go. Now, delete. Now, delete. Moving on. Ooh, do you remember the name of these not supposed to be black, but that's okay. These bad boys, these are called mixed numbers, and they look a lot easier to read if we actually write them like mixed numbers. That's 5 and 3 over 8. And then we also, I'll write this over here, 5. That's a funky 5. That's okay, 5 and 1/2. Now, in order to convert a mixed number into an improper fraction so that we can have a better chance of comparing them, we just do the bottom, the denominator times the whole number. 8 times 5 is 40. Add 3. That's 43. Do not forget, please do not forget, that the denominators just stay the same. All right, next, this 2 times 5 is 10 plus 1 makes 11, and the denominator stays the same. Delete skis. And, oh, no, nope, nope, nope. There we go. And there we go. And there we go. And you know what? I still want some more space, so let's just move. Boop, just like that. Okay. We're ready to compare, right? Wrong. That's because we have, you just said it out loud. I actually heard you. You said we have unlike denominators, and you are correct. So now in order to compare these, what we need to do is we need to make these denominators the same. And now I understand, or I see that 2 goes into 8, so I'm just going to cross out the 2, make it an 8, and understand that to go from 2 to 8, you multiply by 4, and whatever you do to the bottom, you do to the, thank you. So 11 times 4 is actually 44, and again, this is getting a little bit messy for me. 43 divided by 8, and 44, ooh, so close, divided by 8. That means, this one is the bigger. All right. And delete. And delete. Okay. Now, let's go into place value, another surprisingly fun math topic. Remember, place value is the value of the place that the number is in, right? We have ones, tens, hundreds, thousands, 10,000s, all of that good stuff. And then if we go to the right on the place value chart, the number gets smaller, so tenths, hundredths, thousandths, so on and so forth. This question reads, what is the place value of 2 in 4,208.7? Again, key right here. Oops, that's not supposed to be the highlighter. That's supposed to be the pen. The 2 is right here. So recall that the 7 is in the tenths place. The 8 is in the ones place. The 0 is in the tens place. And the amazing 2 is in the hundreds place. Let's go. Number 14. Oh, here we go. Another good one. Exponents. This reads, it is asking us very kindly, simplify the statements below. Okay, number 14. Now, when you see this, Just know that typing exponents on the computer is a little bit difficult, and so it actually looks a little more like 3 squared times 3 to the 4th power. When you have two numbers and they're both the base are the same, 3 and 3, you know the answer is going to be 3 to some power. And in order to understand what power it is, we take a look, make sure it's being multiplied. We take the two exponents and we just add them. 2 and 4, that makes 6. So our final answer is 3 to the 6th power. Let's go on to number 15. Again, it really helps me to write this out properly. It looks like we have b to the 9th power, and then we have divided by b to the 4th power. Now, when, again, we have our bases that are the same, which b and b, we know the answer is going to be b, and the only question is, what is the exponent? And when you have a division sign, all you do is subtract the exponents. So here we just have 9 minus 4. 9, 8, 7, 6, 5. 9 minus 4 is 5. So we have b to the 5th power. Delete. Moving on, anytime that you have a number to the 0 power, this is actually reading 9 to the 0 power, that actually means 1. Pretty simple, but crucial to know. Moving on, we have number 17. I think it's better if we write this out. It looks a little bit neater than the computer version. So this is 3 to the 3rd, and then this is actually a power to a power, which is really cool. And this, my friends, is when we will actually do some multiplication. The 3 stays right there. Now, when you have a power that's being to another power, so it's a power to a power, we multiply. Now, 3 times 2, as you know, is 6. The answer is 3 to the 6th. Not too bad. Not too bad at all. Next up is m to the negative squared, negative 2. If you're asked to simplify a problem like this, really simple, let me show you how to do it. All you do is you put a 1 over and the negative drops off, right? So these two are equal. And delete. Moving on. Ooh, order of operations. Do you know what acronym comes to my mind when someone says order of operations? I think PEMDAS. PEMDAS, which stands for please excuse my dear Aunt Sally. Now, of course, please excuse my dear Aunt Sally really stands for the P is parentheses, the E is exponents, the M is multiplication, the D is division, the A is addition, the S is subtraction. This PEMDAS, please excuse my dear Aunt Sally acronym, it helps us to understand how on earth can we even possibly solve something so lengthy like this, where we have some add, some subtract, some multiply, some divide, some parentheses, some exponents. Well, remember, we always use please excuse my dear Aunt Sally, where we do the parentheses first, the exponents next, then multiplying, division, adding, and subtracting in this order. 1, 2, 3, 4, 5, and 6. In order to follow this, I'm going to start on the left, and I see we have some parentheses. So let's go in there, and within the parentheses, we will, of course, do the exponents before that subtraction, and 6 to the 2nd power means 6 times 6, which is 36, and then we have this minus 6, so it's actually going to be equaling 30. We're just going to bring this one down right here, just like that. Now we have this new and very nice looking parentheses problem, so we need to figure out what to do first. Well, luckily, the old eyes caught this right here, 5 to the 2nd power. 5 to the 2nd means 5 times 5, which is 25. We have this plus 10. Now what we're going to do is we have a negative 8 times 2, which is minus 16. So what we want to do is do the addition. 25 plus 10 is 35 minus 16. Don't be afraid to write basic problems when you're taking your ParaPro exam. 35 minus 16. This becomes 9 and 2, 1. That becomes 19. And we, my friends, are left with 30 and 19. Actually, 30 over 19. So let's just properly write this. 30 over 19. And my goodness, let's please clean this stuff up. Okay. Wonder if that's going to work. It does. Nice job, iPad. Okay, let's go on to estimation. Now remember, there's a total of 30 questions. We're on question 20. You're doing awesome. Nice job for sticking around with me. Estimation it is. Here we go. Let's read this. This looks fun. I love word problems. In a math class, there are, let's highlight the good stuff here, 238 girls and 244 boys. Go back to the yellow. The teacher rounds the total number of students to the nearest 100 for a report. What total does she report? So we have girls, we have boys. The teacher, what's really important here also is to recognize that the teacher rounds the total number. So she found, or the teacher found a total number. So what we need to first do is find the total number 2. 238 plus 244. 4 and 8 is 12. 4 and 7, add 1 is 8. 2 and 2 is 4. Now remember, when we are rounding, what we do, and remember also, really importantly, it says to the nearest 100. Actually, that should probably be a highlight. The nearest 100. So the hundreds place value, as you can recall, is here. And any time we need to round to a certain place value, such as the hundreds, what we do is we look to the number to the right of it. If this number to the right of it is 5 or above, we give it a shove, means it goes up. And if it's 4 or below, just leave it alone, and the number stays the same. However, with this case, 8 is above 5, so it would become 500. Let's see if we have. We do, yay. She would report a total of 500 students for her nearest 100. All right, let's keep going here. Next up, we have single step, single variable, linear equations, really long term, really complex for not being so difficult at all. So I personally like to just write it out. Again, y equals 5 over 8 equals 3 over 4. And what we need to do is we need to isolate this y right here. And so I see that we have a negative 5 over 8. And in order to get rid of the negative 5 over 8, well, we are going to add it to both sides. So we're going to take this plus 5 over 8. And so what I'm going to do here is, let's go like this. And goodbye. And rewrite that y. There we go. However, this to me doesn't feel solved yet. We do have different denominators. And in order to properly solve this, we need to find some common denominators. So we are going to take that 4, make it an 8. We multiplied by 2 on the bottom, so we're going to multiply by 2 on the top. 3 times 2 equals 6. And now we are ready to solve. 6 plus 5 is 11, and 8 stays the same. So our answer is y equals 11 over 8. Is that what you got too? Nice job. Let's go on now to, you know what, I just can't help it. I've got to just keep this stuff clean. Let's go. There we go. All right. Number sequences. So a sequence of number is a pattern, and we have this table. It's kind of like an input-output table where it looks to me like put 1 in, 3 goes out. Put 2 in, 7 goes out. Put 3 in, 11 goes out. Put 4 in, 15 goes out. So what I like to do anytime that I'm given a visual like this, I kind of like to mark on it, draw on it, kind of summarize it in my own words, kind of notice the patterns that I see. For example, I see this goes up by 1, 2, 3, 4 each way. I also see that this is being added 4 each time, added 4, added 4. Let's now kind of, we understand like some things that are going on, but what we really need to focus on is how we go from this x to this fx. So we need to, as our instructions tell us, write an equation to model this. So what equation? How do we do that? Well, in order to do this, what we do is we look at x and we ask ourselves, okay, how could we take other numbers and get 3 out of it? So what I like to do is I like to keep it really simple at first. And I like to say, okay, well, 1 times 2, that equals 2. What if I added 1 to it? Hey, look at that, that's 3. So Now, if it's a pattern or a sequence, we should be able to do the exact same thing down below. So again, if we take 2 times 2, and then we add 1, 2 times 2 is 4, add 1, that's 5, but that didn't work. So we have to go back. You know what, it's just a lot easier if I just, boom. All right, so, but still, I'm not discouraged. As a matter of fact, I am encouraged. Instead of 2, let's try 3. 1 times 3. Oh, look at that. That worked. Let's try 2 times 3. Oh no, that's 6, not 7. So that also didn't work. But again, I'm only feeling encouraged here. So let's try, we tried 2, we tried 3. I don't know, let's just try 4 and just see what happens. So we have 1 times 4, that equals 4. In order to go from 4 to 3, we could subtract 1. I mean, that works. Let's see if it works down below too. All right, so we have, we're doing 4, so 2 times 4. Yes, 2 times 4, that equals 8. Oh, look at that. If we subtract 1, that also works. So multiply 4, subtract 1. 3 times 4 is 12, minus 1. Whoa, check it. It's working. Things are working. 4 times 4 equals 16, minus 1. I think we found it, my educator friends. That to me tells me that we need to write fx, because again, that's what we're solving for, equals, we could say x times 4 minus 1. That to me looks good. All right, nice work on that. Let's go on down to question number 23. Another word problem, yay. All right, every year a local community hosts a popular arts event. Love it, nice. The price of the tickets of the festival has been increasing steadily each year. Don't like it. Okay, let's go back here. Who wrote this anyways? Each year for accommodations and services and such. Okay. The first year the festival was held, tickets were priced at $6. That seems reasonable to me. Each subsequent year, the ticket price increases by 5. That sort of doesn't. Hello, inflation. The question here is calculate the price of the ticket in the 99th annual festival. So again, when I read all of these words, I feel confused sometimes. So what I like to do is I like to summarize what I just read in my own words so that I understand it better. And so from what I get here is the first year, the price was $6. Every year after that, it was plus $5. Whew, and they are looking for the 99th annual price ticket. So if this was just like, what's year 3, then what I would do is I would probably create some type of table, and I would say like year and price, and I would say like year 1, year 2, year 3, and I would do something like that. And I'd say, okay, in year 1, it was $6. Every subsequent year, it's $5 more, so that would be $11 every subsequent year is $5 more. 11 plus 5 is 16. However, I don't want to, and there's just no, well, not only do I not want to, you just will not be able to do that on your ParaPro exam. So I'm actually going to provide, and if you've stuck around with me this far, you should honestly just give yourself a pat on the back. As a matter of fact, we'll do it together. Let's go. Did you hear that? All right, pat on the back, because I'm going to give you like the sword to like defend yourself when you receive a problem on test day like this. It is a very, very important formula, and it helps you find the future number of things. And so if you aren't already taking notes, I would suggest this is like the one thing to make sure that you know. I'm going to write it like this. N to the n equals A plus D, parentheses, n minus 1, where this n is the year that you have to go to. So is this n, same n. This A is the first number that you're given. This D is the difference in the thing, in this case price, that's being looked at. Now, we'll just fill in the blank. We have the year, that's 99, equals 6 plus 5, parentheses, 99 minus 1. Now we use our expertise on PEMDAS, please excuse my dear Aunt Sally, to solve it. So we still have n to the 99th year. Remember this, like, also notice that I'm writing it below. It's like a subscript number. Equals And we are going to 6 plus 5. We are going to take 99 minus 1. That's 98. And now this 5 and 98, this is being multiplied. So we are going to do that multiplication, which looks really, really fun. 98 times 5. Let's go here. 5 and 8 is 40. 9 and 5 is 45, 46, 47, 48, 49, 49. However, we still have this extremely patient 6 up here, where we are now going to add that 6. And 490 plus 6 is 496. And that 496, of course, is the price of a ticket in the 99th year. So check that out. I mean, if you thought $6 was a lot, imagine paying $496 for a community arts festival. Woo! All right. Now we are going to, as you know, you guessed it, I heard you, clean it up, take it out, move on. Area, perimeter, volume, coming up on some of my favorite stuff here. So number 24, I just like to, again, kind of just check out what we have. We have this, we've got that, we've got that, we've got that. Also, you should definitely know what shape this is. Do you know what shape it is? It starts with a T and rhymes with trapezoid. All right, so I think you got it. It's a trapezoid. And in order to find the perimeter of anything, we always add up all of the sides. And this side is 5. It's the same, just like that. And so we are going to take 5 and 5 is 10. 8 and 6 is 14. We've got 24. 24, and do not forget the label. 24M, which stands for meters, of course. Scratch it out, clean it up, and review it. We've got area coming up next. Now the area for a trapezoid, and you're going to have to know the formula to find lots of different shapes. So make sure that you do, and if in case you're not already enrolled into the teacherpreps.com test prep, we give you all of the formulas in one simple place that you need to know for passing your paraprofessional exam. So area of a trapezoid equals, let's go, A equals A plus B divided by 2 multiplied by height. So let's just fill in the blanks. A equals, oh, also, you might be asking yourself, what's A, what's B? This is A, this is B. So the shorter side of the trapezoid is A, the longer side of the trapezoid is B, and the height is right there. So we, going back to it, we have 6 and 8. 6 plus 8 divided by 2 multiplied by 4. Area equals 14 divided by 2 multiplied by 4. Area equals 14 divided by 2 is 7 multiplied by 4. Area equals 7 times 4 is 28. Are you liking how I'm doing this step by step, or do you wish that I would just kind of cook through it? Because personally, I have always really appreciated when a math instructor just went literally step by step. So I hope you do too. So the answer here is 28. We are not finished because we are solving for area, and any time, and I mean anytime you solve for area, you have to put the label squared. All right, so moving on, cleaning on. You know the deal. And problem number 25. Ooh, this is a triangular pyramid. Okay, and also notice here, looks like they are asking us for the volume. Volume is always for three-dimensional objects, and the volume for a triangular pyramid is base times height times 1/3. So we have volume, we have the base. Base is 3 centimeters times the height, 6 centimeters, multiplied by 1/3. Let's go. 3 and 6 is 18, multiplied by 1/3. Volume, 18. I'm just going to put this over 1. Remember, multiply 1 and 3. Remember, when we multiply fractions, we just multiply it straight through, loving the multiplication of fractions every single day of my entire life. And 1 times 3 is 3. 3 times 6 is 18. So our final answer is 6. and that's it. No, I'm just joking. Do not forget the label, centimeters. But what's really, really neat about volume is that it is centimeters cubed, so 3. Here we go, and there we go, and there we go. Nice and neat and ready to go. Number 26, I see that we have a nice chart, and the chart reads number of books read by students in 1 month. Looks like our x-axis is books read. Our y-axis is the number of students who read them. Now let's go ahead and read the actual question. Approximately how many students read read fewer than 6 books in the month? So less than 6 books in the month. I just want to figure this out. Okay, so this looks like this whole thing. Let me just do this in a different. There we go. This whole thing is 2 books read. This whole thing is 4 books read. This whole thing is 6 books read. And they're asking for what? Less than 6 books? Okay. Fewer. Ooh. Approximately how many students read fewer? I actually thought that's good. I was actually going to include 6. Fewer than 6 books. So it doesn't include 6 books, which means it's just this and this. Fewer than 6 books. Hold up. Nope. This is 2. This is 4. That means this is 5. It does include that. Let's go back. I was looking at that and I was like, but now that I'm reading it, I can see it. So we need to, it said approximately, which is great. And so we just want to draw a straight line, our best straight line. Okay, so that to me, it looks like a little bit of, this is 5, this is probably 6, 7, maybe 8. We'll just say 8. And this is about 6. So we have 6, 8, and right here is probably about 2. So 6, 8, and so, well, first of all, 6 and 2 is 8, and 8 and 8 is 16. So approximately how many students? Approximately 16 students read fewer than 6 books in a month. So scatter plot, study hours versus test scores, x-axis, hours studied, y-axis, actual test scores. First and foremost, I like what I'm seeing here because I kind of notice a little pattern increasing like that. Okay, cool. Got it. Let's read the problem based on the scatter plot data. There we go. If a student studies 7 hours per week, what is the most reasonable prediction for their test score? Most reasonable prediction I see here is 7 hours. So let's go up and use the green. Now if we just go up here, this, it's in this range right here. So let's just kind of draw another line. And boom. Now I noticed that it's between 50 and 60, and I also noticed that the answers are approximate. So between 50 and 60, we got it. Nice. There we go. All right, now moving on to questions 28, 29, and 30. It says to use the following information. Let's go ahead and read this. Mr. Lee documented the lengths in hours of students' screen time per day. All right, let's look down here and see what we're working with. All right, I see first and foremost that we have a string of numbers. Looks like 1, 2, 3, 4, 5, 6. We have 6 numbers, and oh, now I see what we're looking for. We are going to be asked to calculate the mean, median, and mode. Let's go ahead and make sure we give you a review on these topics. So remember that mean is another way to say average. So in order to find the average, what we want to do is we want to add up all of these, and we will do that, and then we'll divide by the amount of numbers that we have. And if we have 6 numbers, then that's what we'll divide by. So let's go ahead here, 10 and 8, that's 18. Let's go here, 6 and 6, that's 12. And 4 and 2, that's 6. Let's keep adding these up together. All right, 6 and 12, that's going to be 18. And then we have 18 plus 18, and that is going to be 36. All right, now 36 divided by 6 equals 6. So our mean is 6. Nice job. All right, let's go on to the median. Now, the important part about the median is that first we need to make sure that all of the numbers are written from smallest to largest. So let's go ahead and make sure that they are 2, 4, 6, 6, 8, 10. All right, excellent. They've already saved us the time. Sometimes the numbers will be written in a different order, and the first step to find the median is to place all of the string of numbers in ascending order. So from smallest to largest. All right, now we've already done that. So what we want to do is we want to find the middle ground. So in order to do that, it kind of helps me to review the numbers and just kind of cross out. There you go, and cross these out. And now we're left with these two numbers right up top. And so we have 6 and 6. And now if there was just a middle number, then that middle number would be the median. But because there are two numbers in the middle, what we need to do is we need to find the average again. So that would be 6 plus 6, that equals 12. We'll take 12 divided by 2, and that gives us a median of 6. So we not only have a mean of 6, looks like we also have a median of 6 as well. Now let's go ahead and calculate the mode. And remember the mode is the number that occurs most frequently. So I see from these numbers that 6 occurs 2 different times. We have 2 6s, but we only have 1 2, 1 4, 1 8, and 1 10. Now, just to prepare you for your ParaPro exam, if we only had 1 6, meaning all of the numbers only occurred one time equally, then there would be no mode. You would actually write no mode. However, because we do have a set of numbers that does happen to occur most frequently, that mode is 6. All right, that's the end, and we together have completed a total of 30 questions similar to what you will receive while taking your official ParaPro exam. So if you liked this video, if you found it helpful, please give it a thumbs up. If you downloaded this resource, go ahead and click this link to get access to our complete ParaPro test prep. Wishing you all the best on your upcoming studies, and let us know if you have any questions at all.